Okay, so thank you very much for coming. Good morning. My name is Mike Oram. I'm here to talk about progressive web apps and offline development. Just a little bit about me. So I'm a full-stack developer. I work in LAMP and Node. I run something called Maiden Academy, which is a training company in Bath in the UK. Basically, I learn new stuff and then I come to conferences and teach other people it. So today, as I said, we're talking about progressive web apps. So what is a progressive web app? If you go to Wikipedia, it says this. Progressive web apps are experiences that combine the best of the web and the best of the apps, which sounds great, but doesn't really tell us a massive amount about what it actually is from a practical perspective. So that's what we're going to look at. So progressive web apps, first kind of the concept came around in an article written by Alex Russell in 2015, where he was talking about native applications versus web applications. And in this article, he talked about how a progressive web app should appear like a native application on your mobile device, that they possibly could work offline, and that they should be operating system agnostic. Now we're not quite there yet. The support is getting better, but if you're on the latest versions of Windows, Android, iOS, or OS X, then you can use this. It's just not fully feature supported, which we're going to look at a little bit. But the crux of it is that these days a PWA, or a progressive web app, is basically just your web application, the apps that you've all already got that run by the browser, with a little bit of extra JavaScript to make it do some cool things, and that's what we're going to look at. The idea behind a PWA is that at the moment with a native app, you have to, if you want to use an app, you have to go to an app store, download the app, wait for it to install, then open it and start using it, if you haven't already got it, of course. The idea with a PWA is that this is kind of flipped on its head, and rather than having to install an application first before you can start using it, you just go to a URL and you start using the web version of that application, and it will just install silently in the background, so that the next time you come back, it's quick and it's ready to use, and it works like a native application. We're going to have a look at that. Basically, in order to trigger the PWA install, in the background, you have to be considered what Google coin as a regular user. Now, what they consider regular users are if you visit a URL or an application at least twice with at least 5 minutes in between. Now, I don't have regular that actually makes you, but that's what that's the current definition. So, what that actually means is you go to the URL like this. It loads in your normal browser and it triggers that pop-up. Click install, and on your home screen you'll get an icon up here like a native application. You can then click that icon and it will open the same page that you were on previously, but in a full screen standalone mode is what they call it. So just see that again, it's quite a quick animation. There, so no URL bar, looks like a full application. Sorry, that's quite quick. Basically allows you to treat that application from that point onwards like a native app on the phone. Now this one doesn't have a defined icon, but we'll look at later how you can actually change the icon so that you don't get the Chrome icon, so you actually get your standard whatever icon you want. So why do we want this? Why is PWA a good thing? Let's have a look at some case studies. Tinder were one of the first big applications to do this. They obviously have quite a popular mobile app. When they turned their online version into a PWA, their web version into a PWA, they actually cut their load times from 11.91 seconds on their native app down to 4.69 seconds, which is a reasonable increase in speed. Their PWA is actually 90% smaller than the native Android application. How about Uber? So Uber have done the same, and theirs is only 50K when gzipped. This means that if you're traveling and using Uber in somewhere that you're not familiar with, where maybe you don't have 4G, then now actually you can load the Uber's PWA in less than 3 seconds, even on a 2G network, which is very important if you're lost somewhere that you... Trivago have also done this. So it's not just about speed, it's also about user engagement. Trivago's app actually wasn't all that popular because people don't just want an app sat on their phone that they're only going to use a couple of times a year when they go on holiday. But people often use they have a high user engagement on their actual website, particularly from mobile. So by implementing their PWA, they increased their user engagement versus their native application by 150%. This obviously resulted in higher amount of clicks through to their hotel offers, 97% increase, and actually also came with offline support, and they found that 67% of their users are still browsing their application when offline, so they're not losing users as soon as the internet drops out. Okay, last one, Pinterest have implemented the PWA too. Their user engagement increased by about 60%. This resulted in a 44% increase in user-generated revenue from ads. And ultimately, the amount of time spent using Pinterest has gone up by about 40%. So we got some pretty good case studies as to why we should be doing PWAs. So how do we do a PWA? How do we convert? So actually, you need 3 things for your application to be considered a PWA. I've got 4 on there because it made my slide symmetrical. So you need HTTPS, but you're all already doing that, obviously. You need a service worker, which is a bit like a client-side proxy, and we're going to have a look at that in a minute. And you need a web app manifest file, which is a JSON file that allows you to configure your PWA settings, basically. And we'll have a look at that too. Now, the last one you don't actually need to be considered a PWA, but you probably want to be using it anyway. So we'll have a look at that too, a little bit. So what is the web app manifest? As I said, it's a JSON file. You link to it in the head of your HTML, just using the rel equals manifest, and then the location of your JSON file. Inside your JSON file, it allows you to basically specify all of the things, all of the settings that your users see when they launch your application. So that's the default background color of your splash screen whilst it's loading. It's the icon that gets installed on their home screen. It's the name of the application that gets installed on your home screen. It's the initial URL that will open when they click on the icon from their home screen. It's how the application will open when they first click on it. So the GIF that I showed you earlier was using display of standalone, so it opened with no URL bar, and the device treated it like a standalone application. But actually, that's optional. You can have it open in your browser or standalone. And there's a whole list of different settings that you can put in your web app manifest. These are basically the ones that you want, but there are a load of other ones that give you a lot of control. So that bit's easy. So how about the service worker? So as I said, this is a client-side proxy. It runs in a separate execution thread from your standard JavaScript, so it won't block your normal JavaScript from running. It doesn't have any DOM access, which when you first start to do this, you'll think is a real pain, and then you kind of realize what you're supposed to do with service workers and realize that you probably don't need it anyway. But there is a new API called the post message. I say new, it's not that new, but called the post message API, which allows you to pass messages from your service worker back to your standard JavaScript front end, so that your JavaScript can then pick those up. It's event-based, and then update your UI. Basically, your PWA has the ability to interact with all your network requests. So any HTTP request or response, your service worker has access to that request and response and can manipulate it and interact with it. It's most commonly used for cache management, but we can do a lot more with it. So in order to implement a service worker, it's actually really easy. You just need basically this bit of JavaScript in the head of your page. Generally, the advice, because this is so small, is to actually just put this straight in the head rather than linking it from a separate file so that it loads straight away. You don't have to do an additional request to get it. Basically, we just check if service workers exist in the current browser. Obviously, they're not fully supported. If they do exist, then we specify the file of where our service worker is. We give it a scope, which is how much of the current domain that service worker has control over. So by giving mine the scope of / it means I can control everything. And then we register that and we catch any errors just in case there's a problem. Okay. Now inside the service worker file, sorry, wrong slide. So yeah, that's literally it. That's actually registered a service worker. And actually, technically, as far as Google and everybody is concerned, if your service worker file is actually empty, but you've registered one, provided you've got a web app manifest file and you're running over HTTPS, then you've made a PWA. You're done. You actually don't have to make your service worker do anything. Probably don't do that, but in theory. So let's actually make our service worker do something. So inside the service worker itself, it's, as I said, it's event-based. So we hook into the install event, and then here we can control what's happening. So all I'm doing here is I'm using the caching API to open a new cache and then just store a CSS file in it. This means that from now on, any request that goes to my.css file will pull it out of my cache instead, which is quite nice. As I said, this is the most common usage for a service worker, but we're going to look at some other things. As I said, it has access to all of your network requests, all of your HTTP traffic. So here I'm hooking into the fetch event, which is the name for an HTTP request or an AJAX request these days, if you're used to using the fetch API. This will hook into every or any HTTP request that comes out of your application and then allows you to decide what happens with that. So in this one, I'm just checking whether it's in my cache, and if it is, then I'm going to get it out of my cache and send it back, and if it's not, then I'll actually do my fetch request. So that's controlling HTTP requests and using caching, which, as I said, is the most common usage. But we can do a bit more with this. So here I've got an example of only pulling data actually back from the server. If the data is stale, now I've decided that my data goes stale after 5 minutes. So no matter how many times somebody requests some data from the server, if the last time that I got the data from the server was over 5 minutes ago, then it will go and get it. If it's less than 5 minutes ago, then it will just pull it out of my cache. So earlier we were caching files, but actually you don't have to. You can cache anything. So if you're pulling data back from a JSON API, for example, then you can just put that in your cache and save that for later, so that the next time somebody does a request, if you've already got the data and it hasn't yet changed, then you can just pull it straight out of the cache and not actually bother going to the servers. This works with any AJAX request, any HTTP request, whether you're using the fetch API or whether you're using whether you're using XML HTTP request as well, it will still work. So basically what's going on here is the initial request to your API goes out, gets the data, on its way back we store the data, and then we display it to the user. User interacts with your page in some way, they refresh or they go to another page which requires the same data on it. The request goes out, but this time the service worker picks it up and decides how to respond with it. So have we already got that data? If so, let's just respond with the data from our cache. If not, then it will go and get it again from the server. That responds, and your front end knows no difference as far as it's concerned. Your fetch request has come back as standard, and then you can update your UI, your DOM, however you see fit. So the bit that I'd like to look at is the storing data. At the moment, I've talked about the cache API, but that's not the only way of storing data on the front end. So we're going to have a look at that in a bit more detail. So there's basically three places on the front end, or three things that we can use to store data. There's the cache API, which I mentioned. This is generally used for caching files, but it can be used to cache data, but it will store it as just plain text. That's not ideal if we're storing JSON, or particularly if we're storing large amounts of data. If we're storing JSON or XML, we want there's no way of querying it. You just have to pull the whole thing out. So other alternatives, there's the local storage API, the HTML5 local storage. This is really popular because it was the first client-side storage facility to come out, and it's synchronous, so it's really easy to use. You don't have to worry about callbacks or promises or anything like that. But actually, because it's synchronous, it doesn't work with the service worker, so you can't use it. So if you're already using a local storage on your application, unfortunately, you can't use that from your service worker. It just doesn't work. So the alternative is IndexedDB, which is an asynchronous equivalent almost. It's generally used for storing extremely large amounts of data, or large amounts of data. Extremely, maybe a bit over the top. But it's really efficient for doing high performance searches. You don't have to pull everything out because it doesn't actually store it as plain text. It stores key value pairs, and it actually indexes your data. So it's basically just like a front-end database, but in your user's browser. So you can pull the data from there very quickly. So, as I said, it's a client-side storage. It's designed for large amounts of data. It's usually JSON, but it doesn't have to be. You can store pretty much anything you want in there. It uses indexes for performance. It's asynchronous because it's based on the Promise API. And it's actually a permanent data storage. So that's one of the things that people often don't get when I talk about IndexedDB, is that actually your user can leave and then come back and the data's still there. It won't expire at all. It's not like a cookie, or there's no expiration on it unless you delete it, or they uninstall the browser, or they go in via the dev tools and actually manipulate it themselves. The data won't disappear. It's permanent storage. As I said, it's pretty quick. So depending on your device, it tops out at about 1K reads per second. Writes depends on the amount of data you're writing, so I can't give you stats on that, but it's not as quick as reading. Generally, it's much faster than doing a network request to your backend. For small and medium-sized data, obviously there's no overhead, there's no waiting for the internet. For large amounts of data, it varies depending on what you're doing. So how do we use IndexedDB? It's actually pretty easy. In any browser which supports it, which these days is all of the modern ones. We simply open a new database. We open a transaction, give it a database name. This one is called to-do list. We give it the permissions that we want, so read, write. And then we open an object store, which is like a table from your database. Once you've done that, you've then basically just got a connection to your database table, and you can start adding stuff. So here I've just added an object with a key value pair of my name, and that'll just store, in this example, store some JSON with the key of 1. So as I said, it's indexed. Then we can get it back out by just calling get with the key, and it'll give me the data. It does do auto-indexing as well. It will auto-increment your index, so you can just leave that one off, and it will just do it for you. And then you can update using put. So here I've just changed my name to Charlie and updated the key of 1. So if we come back and have a look at the code that we saw earlier, where we were doing a network request if the data had gone stale after 5 minutes. This time, rather than storing anything in the cache, we're just going to put it in into IndexedDB using the ID from the request. And then if the data's there, then we can get it out, and if it's not, then we can go to the server, fetch it, and put it in and store it. Okay, so that's just some of the things that we can do with our service worker. And actually, now that we've started to store data in the on the client side, we've basically achieved offline development. The fetch request doesn't go to the server. You now can pull data straight out of your browser. Your application will work offline. But there's some more stuff that we want to do with this. So the first thing you need to take into consideration when you're doing this offline development is the UX implications for your app. Should you be doing offline? If you're building something like a finance app that's tracking stock market prices, you probably don't want to be caching that data for 5 minutes. Then people are quite a long way out of date. Or train times, for example. If it's a live train app, then you definitely don't want to be caching it. But if it's looking at stuff for tomorrow, then 5 minutes, maybe not too bad. But definitely think about your the UX implications of working offline and whether whether that's actually a good thing for your users. My big bit of advice for this is to make sure that you update your UI. So tell your users that they are offline. They might not have realized. And I've seen quite a lot of these applications where they've got offline support and then they don't actually show a message or show any notification to tell their users that they're no longer connected and the data they're seeing is not necessarily the latest. So use the post message API that I mentioned earlier and actually tell your users that they're not online. We're going to have a look at that. So from inside your service worker, we can actually detect whether you're online or not. This bit in bold here is doing your fetch request. That's the bit that's actually going to the internet. So we need to we're going to drill down into that a little bit more. Now this code gets quite long, so I've just commented it rather than actually providing the code for you, so that you can see the principles. But basically, we do our fetch request. If the request fails, then we catch the request. In here, the error will contain a message that will say that the network is unavailable. So you can check that. And if the network's unavailable, then we can do something about it. So maybe we try and pull it back out of IndexedDB where we stored it earlier, and then update the UI, or whatever the relevant thing to do when they're offline is. Now we can also do, without your service worker, you can also now update the front end using a new flag inside the navigator object called online. This is just a Boolean that will return whether the device is currently connected to the internet or not. It will basically just say true if you're connected and false if you're not. There's also two new events called online and offline, which fire on the window when the status of your connectivity changes. So we can hook into these events, the online and the offline events. And this one just updates a very simple div or whatever in the page to just show the users that they're no longer connected. This can be done without the service worker at all. So even if they're not making fetch requests, if they're just scrolling through a page that already exists, this will just update without them actually having to refresh or go to a different page. They'll instantly get a notification that will say you're not connected anymore. So we can come back to this slide. So we're doing our initial request to our API. Goes and gets the data, store it in IndexedDB, and we display it. The user then performs a page action, like a page refresh, or changes pages to a page that requires the same data. The service worker kicks in and performs a fetch request, or falls back to IndexedDB if the network is down, and pulls the data back out of the cache. And then your front-end code can just update the UI as if it had data back from a standard request. So service workers also come with this thing called background sync. This is actually really useful for offline development, and I strongly suggest using this if you're going to do the stuff I've just talked about. So I had to kind of squeeze all my code onto one slide here, so it's a little bit condensed. But the top bit is sort of your application. So here I've got an event listener on a button. When we click the button, it's going to make an AJAX request to update my train times or whatever. And rather than doing a standard fetch, I'm actually using the background sync API to register this event called update trains. That sync event can then be picked up inside your service worker, where you can hook into the tag name, in my case, update trains. And that uses this thing called event wait until, and it will call that function as soon as you're connected. So it will just sit and wait whilst you're offline, and then as soon as your connectivity comes back, it will make the request for you. So you could do that based on a button click like I have. You could do that in the event call, in the event callback when as soon as your application goes offline from the front end detection. And it will just sit and wait in the background whilst your user's not online, and then as soon as they come back, as soon as the connectivity comes back, it'll make that request. The promise will resolve, and you can update your front end. So I've talked all about the things that you can do and the good things about PWAs. So what are the limitations? Well, it varies between operating system and device, but at the moment there is a 50 megabyte limit on iOS for the amount of data that you can store. That's a hard limit, and it's a complete limit, so it's not just files, that's data in IndexedDB, it's everything. You have a maximum limit of 50. Yeah?
Is that for one application or for all PWAs?
One.
Oh.
Yeah, per domain.
Yeah.
Okay. On Android, last time I checked, it was 2 gigabytes, but they keep changing it. But it's probably more than you need. iOS also has this auto-delete thing, which they think is really useful, but it's probably really annoying. Basically, if you don't use the PWA for a couple of weeks, iOS will just delete it. It won't actually delete the icon from your home screen. That will stay there. So as far as the user is concerned, nothing's actually happened. But in the background, all the files, the cache, the IndexedDB data, everything just gets removed. So the next time that they open it, it will then re-download everything, which isn't a big problem, but it does mean that if they haven't used it for a couple of weeks, that the first load will be a lot slower because it has to go and re-download everything. And it means that you have to take this into consideration because your first load needs to check whether they've got the stuff that they need. You can't just pull it straight out of IndexedDB if it's been deleted. Now there is a talk in the next slot about the mobile web API, the browser API stuff, so I'm not going to talk about that too much. But that stuff is still under development. It's really cool. It does give you a lot of power, but there's some limitations from PWAs, particularly from service workers. So your service worker doesn't have access, basically, to most of these features at the moment. That does vary depending on your device, but things like Bluetooth and your touch ID, so your fingerprint scanner, your facial scanner, that kind of stuff, your service worker can't access any of that stuff. So if it needs access to any of that data, you have to pass it to and from using the post message and accessing it from your front end. iOS doesn't have access to push notifications or any Siri integration. On Android, you actually can access the Google Home Assistant and use push notifications, but not on iOS. So what does this mean for you? Well, first thing is to brush up on your JavaScript, probably. I had to. Don't bin your native application just yet, but maybe soon. It'd be nice if one day in the future we don't have to maintain 2 code bases and we can just have one web application which will work across the board. but I don't think we're quite there yet. But it's still worth implementing now, and then possibly one day we will be able to get rid of native applications altogether. Ultimately, the big thing that it means for all of us is that there's less HTTP requests. There's going to be less traffic coming from your front end to your back end because we can cache stuff and we can control what's happening on the front end a lot more. Obviously, there's all the UX implications that I talked about earlier. But the main benefit of this is that maybe we'll need smaller servers or we'll have to worry about less traffic. It's only a good thing. So some resources for you. Servicework.rs website has a whole bunch of, they're not tutorials, they're literally just code samples of all the different things that you might want to be able to do with a service worker. So you can just, this is literally a screenshot of the page. You just go there and down the left-hand side, there's just all these different things that you might want to be able to do. Caching, different kinds of caching, different kind of network background sync stuff. Basically all of the stuff that I've talked about today. You click on any of them and it will give you the code for how to do it, and a very simple introduction to it. It's a really great resource. PWAstats.com. This is where all of my stats from today have come from. It's basically just a whole list of testimonials or case studies of applications that have implemented PWA, and then the differences that they found. So you can go and read up about it because there's actually quite a lot of them now. So thank you very much.